Welcome to our final lesson in Unit 2, Inequalities. In this lesson, 7.5, we'll be graphing linear inequalities and using linear inequalities when modeling real-world situations. So a linear inequality is an inequality that involves a linear function. Okay, and you'll see what I mean by that here in a second. Each point in the region is considered a solution to the inequality, and the solutions of an inequality are all points within the boundaries of the solution that make the inequality true. Okay, so any pair of x and y points that make our inequality true is considered a solution. So let's look at these. So in each point on the boundary line here, when we have a dashed line, each point on that line is not considered a solution. Whereas if we use a solid line, then any point on that line is considered a solution. So think of these solid and dotted lines as your open and closed circles when we just were looking at some basic inequalities. Now that we have linear inequalities, we're going to need that coordinate plane, and we're going to graph our solutions on the coordinate plane. And so we have lines drawn now, and our lines are going to be the boundary lines for our inequality. So if you look at our first example here, and I'm going to change mine to a highlighter here. So we have y is greater than x plus 1, and that is the line that is drawn there. So now I want you to ask yourself, where is y greater than? Is it above that line or below that line? In this case, it's above the line. So any region above that line, not including that line, would be considered a solution to that inequality, y is greater than x plus 1. On the other side, in our second inequality, we have y is less than or equal to negative 2x plus 4. So again, notice we have that line y equals negative 2x plus 4. That is graphed, all right? We use that solid line to include that line as our answer. So any point on that line would make our inequality true. And then the numbers to the, let's use red here. Okay, any numbers in this region, notice how I'm coloring it all in here, is going to make that true. So again, think about this. An easy, quick check is, let's pick our origin here, which is 0, 0, right? So if you were to plug in 0 is less than or equal to negative 2 times 0 plus 4. Okay, when it's all said and done, we get 0 is less than or equal to 4. That is true, right? If we were to pick a number outside here, okay, outside that, say in this region here, then that wouldn't make a true inequality statement. That would be a false statement. That was not part of our solution. So let's look at the example here. So in this case, we have 4x minus 3y is greater than or equal to 6. So again, we are looking for values that will make this true, x and y points. Okay, so I'm going to rearrange this one into slope-intercept form because I like to graph in slope-intercept form, and I know some of you do as well. So my first step is to subtract 4x from both sides of the inequality here, and I'm left with negative 3y is greater than or equal to negative 4x plus 6. Okay, I'm going to divide everything by a negative 3. Yep, that bell's going off in your head, isn't it? I got to flip that inequality sign around. So I'm left with y is less than or equal to 4/3 x. And notice where I'm placing that x. That x is in the numerator. Be careful. I've mentioned that before. And then minus 2. So now we have a y equals mx plus b slope-intercept form equation, or in this case, inequality. We can graph our y-intercept of negative 2. I'm just going to put a little dot right there, negative 2. We're going to rise for 1, 2, 3, 4, and run 3 in that point right there. And our line is going to go something solid or dotted. It's going to be a solid line that goes something like that. Okay, and so now we want where y is less. So where is y less? Above or below that line? Think about where is y less. Y is going to be less below that line. So any region, any point inside this area here is going to be part of our solution. So again, if you want to do a quick check, let's pick a point that's pretty safe in your region. And in this case, let's pick 4, -4. Okay, let's put that point 4, -4. So x is 4, y is -4, right? So x is 4, so I'm going to replace the x with 4, and then our y is -4, and that needs to be greater than or equal to 6. And we do some math. 16 plus 12 is greater than or equal to 6. That means 28 is greater than or equal to 6. That is true, and so we did pick a good point there to check. And here's a great example of a real-world situation where we have an inequality. So we have a budget of $24. We can spend no more than $24, and we need to buy streamers and tablecloths. Streamers cost $2 and tablecloths cost $6. Now, in looking at our graph that they've started for us, I noticed that streamers is on the x-axis, so I'm going to let x be the number of rolls of streamers, and then y be my tablecloths. Now, think about how you'd write this equation if this were an equation. In this case, standard form is going to be your best bet. Don't try to even write a y equals mx plus b inequality here. Okay, so remember, streamers are $2, and then tablecloths are $6. Okay, and so we want to buy a combination of streamers and tablecloths, and that must be less than or equal to $24. See how that works there? Okay, so in order to find all possible solutions, we want to graph this. And using our intercepts are probably going to be the best. So if you look at this, our y-intercept is going to be 4. And our x-intercept is going to be 12. Okay, and we're going to use a solid line because anything on this line could be a potential solution. Okay, and then in spending money, remember we're going to want where it is less. We can't go over budget. So any point in this region here, any combination of these streamers and tablecloths is going to give us an option for decorations for our party. Okay, so we could buy nothing, no streamers and no tablecloths. That's 0, 0, right? That point right there, that 0, 0, that fits our story. We're spending less than $24, so that works great. So any combination there, and even the combinations that are on the line. So just think about this situation and how you could buy all streamers, all tablecloths, a little bit of both, or none of either of them, and they would all still work.